All right. Welcome to Distance Learning Day 1 in 8th grade. I think you're going to enjoy the next few sections because they're not too difficult. I think they're quite nice, actually. Hopefully y'all did all right with Chapter 12. Moving to Chapter 13 today, though. And really, there's only a slight twist to what we're doing, but nothing really is that new. So, the distance formula. You might remember the formula. You might know that little song. Is there a song? No, that's the quadratic equation. JK. But, pretty easy. So, formula D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. It's the distance between 2 points. So, the book so kindly gives us 2 points. -4, 2, and 2, -1. I am not good at doing things in my head, so I always have to label things. So I always, up above, label my coordinates, x1, y1, x2, y2. It doesn't matter if you labeled this one x1, y1, this one x2, y2. It'll all work out. So, distance, square root, x2, 2, minus x1. Ooh, tricky right away. Double negatives. And then y2, -1, minus y1 squared. So that's going to be the square root. 2 minus -4 is 2 plus 4, which is 6 squared, plus -1 minus 2 minus 3 squared. That's going to be 36 plus 9. It is not -9. Anytime you square anything in here, it will be a positive number. That is the square root of 45. And you might be like, cool, I'm done. The answer is the square root of 45. No, it is not. Always, always, always check to see if you can reduce this radical. That is 9 times 5. 9 is a perfect square root. That means its square root gets to come outside. So it is 3 square root 5. And that is the simplified distance between these 2 points. I think that's straightforward enough. So, from there, we actually apply this to circles. So this is the review part. Now we apply it to circles, which really isn't that difficult. I think I just bumped it with my hat. The book shows you the super cool and interesting proof for the equation of a circle, but we're just going to get to it. So, you'll see the theorem, equation of circle, x minus a squared plus y minus b squared equals r squared. And what that means, and I'll show you in a bit, center is at a comma b. Again, be careful, there's negatives in this formula, minus, minus. And a radius of r. So, do we want graph paper? No, we don't need graph paper yet. The book gives you the example of x minus 1 squared plus y plus 2 squared equals 9. Please make sure that you don't forget to put these squared signs. If you don't have them, it's not really a circle. So, if you look at that, you see minus, that means there's this 1 here. A is 1. Now you'll see here, it's a plus sign. That means from this equation, minus, for it to be a plus 2, you need another negative sign. So, B is negative 2. That's the only thing really that'll trip you up here. And here, r squared, 9 is 3 squared. That means r is 3. That means this is a circle with the center at 1, negative 2, with a radius of 3. So if we do a quick sketch, let's see, 1, negative 2, the center would be right there, right? And then I like to do the lazy man circle, which means radius of 3, which means I would go over 1, 2, 3, put a dot. I would go up 1, 2, 3, and I would go left 1, 2, 3, and then I would go down 1, 2, 3. And the lazy man circle, again, why use graph paper and a compass and not draw this, because that's definitely not the best circle I've ever drawn. But you get the idea. That is the radius of 3 with the center at 1, negative 2, using fancy formula from above. So, according to your book, we're done. Let me do one example showing to you why did we need the distance formula for this section, because right now I don't understand why that was included. So, let's look at number 36 in our book. It says the circle has center at, what is this? Negative 2, negative 4, and passes through 0.38. Seems simple enough, right? So, again, the lazy Mr. Hill always labels x1, y1, x2, y2. So, step 1, what do we need for a circle? We need the center. Cool, they gave us. We need the radius. How do you find the radius? Well, if I have the center and another point, if I found the distance, that would be the radius, right? Right. So, I need to find the distance between these 2 points. So, square root of x2 minus x1 squared plus y2 minus y1 squared. So, x2, 3, minus x1 minus negative 2 squared plus y2, 8, minus y1, negative 4. Again, another double negative. So, 3 minus negative 2 is 3 plus 2. That is 5 squared. Plus 8 minus negative 4, that is 12 squared. So that is 25 plus 144. What is that, 169? I think. 169, and that is 13. Nice of them to give us a whole number. And that will be the radius of your circle. So now we have the center and the radius. We wrote down before, right, the equation of the center of a circle. So it's going to be x minus negative 2 squared plus y minus negative 4 squared equals radius squared, 13 squared. And you don't want to leave it like this. So simplify it. Y plus 4 squared equals 169. And am I correct? I am. Give yourself a nice box. Right, yo, because that was a gangsta hard problem. And that's about it. That's about as hard, I think, as it gets. I'm probably lying. You guys will be like, Mr. There's harder ones here. But that's about it. So hopefully that was manageable for you guys. And I'll catch with y'all tomorrow.